Hello Flatliners, my name is Dave Marsh. Start looking into NASA and things, it doesn't take long to see through NASA stuff these days, and the rest of the space agencies, ESA, Roscosmos, all of them, they're all up to no good. My own videos, ISS Smoke and Mirrors, where you can clearly see that they're using harnesses, augmented virtual reality, vomit comets sometimes. They use all the techniques. For the first month, I was literally walking around in a daze, you know what I mean? Like this stupid kind of grin on my face thinking, what the hell's going on? Literally measured the moon as it passed my field of view. But what I did to try and see if my observations were good enough, I actually compared them with time and date. So how would you measure the speed of the moon on time and date? So what I did, I used the meridian passing, the time it takes to occupy the moon. What I did, I measured the time it took to get to that same spot the following day. Yeah, and I measured that, used that as a time gap. And what I noticed is there was huge differences in times from one part of the cycle to the next. But when you looked at Kepler's law, then you looked at all the data what I got, because I did it over a year. Yeah, the moon literally was like a heartbeat. It was like speeding up, slowing down, leveling off, speeding up, slowing down, leveling off. It didn't have that gradual increase and that gradual decrease. Now, a lot of globalarists say, oh, you've actually measured the rotation of the Earth. I'm like, really? Well, firstly, it's stationary. And what I was doing taking all the delta times from the moon, everything beyond 24 hours, because we know the moon's got a mean time of 24 hours. I literally had to remake a video just to show that what I was doing is measuring the actual speed of the moon and not the rotation of the Earth, because it's stationary.
Our next speaker, Dave Marsh, the Moon Man he's been known as, is from Nottinghamshire in the UK. He's an up-and-coming figure to the occasion of intense current research, methodical scientific study of the moon in conjunction with the flat Earth operations of the luminaries. Dave has begun to be offered invitations to speaking at UK and USA events, where he presents his fresh findings and reports, which is conducted over the past 2 years, that are directly challenging to the mainstream science theories. So it looks like a great session to look forward to. Please welcome to the stage, Dave Marsh.
Thank you very much. Can you hear me okay?
Skip the intro. Yeah, we'll skip the video intro. We all know you.
Yes, okay, we'll kick it off then. So, can you see that okay? Is that all right, yeah?
Right way
Upside down here in New Zealand.
Sorry about that. Is that better? Okay, so thanks for inviting me here. It's been a great experience up to now. You know, I've come all the way from the UK. Travelled probably nearly 12,000 miles to be here. I'm really looking forward to doing this presentation. Thanks for asking me to come, Adrian. So my presentation is basically about the moon, about observing the moon, but from a flat Earth perspective. Just a little bit of a disclaimer before I start. All the observations I made are my own observations, yeah, and I've drawn my own conclusions on the back of my observations. I'm not asking you to believe me, like we've heard in the past. I would recommend that you do your own research and come to your own conclusions. But firstly, am I a scientist? No, I'm not. I'm just a normal guy. My name's David Marsh. I'm a warehouse operative from the UK. I'm currently in a managerial position. My managing position got me in quite a lot of trouble from the UK convention, so I'm not going to go too far into the details on that. So, first a quick message from Brian Cox. Perhaps they could put this quote below everyone attending this conference is a shitbox. Now, that's what Brian Cox thinks of these kind of conferences.
There is absolutely no basis at all for thinking the world is flat. Nobody in human history, as far as I know, has thought the world was flat.
So, no one in human history, as far as Brian's concerned, has thought the Earth was flat.
Well, what about every single ancient civilization in history? I'm sure you remember what Mark Sargent showed and Robbie in relation to all the ancient cosmologies. As you can see here, this is early Greek cosmology. Yes, even the Greeks thought they lived on a plane. I mean, many of the Greeks now believe it was a geocentric Earth back in the early 2nd century BC. But before that, all the ancient civilizations believed we lived on a flat surface with a firmament above. And if you look at the Egyptian cosmology, it doesn't really look like a spinning ball in outer space, does it? There you can see you've got the flat surface and the firmament overhead. A lot of people think that flat Earth is some kind of psyop what's been planted on us in the last few years to see how we'll react. Well, when you look back into the history of flat Earth, what you'll find is it's always been there, flat Earth. And this is an early map from Cosmas, the Egyptian monk from the 6th century. And he was a big believer in the flat Earth, you know what I mean? So flat Earth has been around forever. It's just been hidden really, really well. So this is a little quote from Nikola Tesla. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. Like we've mentioned before, a lot of the stuff we're taught about the heliocentric model is theory. Theory on top of theory on top of theory. It's all theory-based. There's no facts or real observations. Now, these days, how I see it, the only people actually making real observations today are flat earthers. You know what I mean? We're the ones going out with the cameras and we're zooming in on these buildings at a distance what shouldn't be seen. You know what I mean? We're filming the moon, we're filming the sun. Everybody does their own little part. And what I was involved with earlier this year was a laser experiment with a guy who calls himself Dr. John D. Now, we went to a place in the UK called Brighton and Worthing, and what we did, we set up some lasers, and we basically did a laser experiment between 2 points over a distance of 9.5 miles. So this was at Worthing Pier, and you can see Dr. John and his team setting up at the Worthing site. This is where we set up, myself, at Brighton Pier, 9.5 miles away. As you can see in the distance there, that's actually the Brighton Promenade. So this is a zoom from Brighton to Worthing, and this is the third time we've actually been to Brighton to make this observation. What we've encountered before is a lot of refraction, you know what I mean? A lot of the conditions weren't right for it, but on this day in, I think it was back in February, the conditions was right. And on previous occasions, what you're looking at now on screen, you couldn't actually see that from Brighton. It wasn't visible. But on this day, like I say, the conditions are right, the sea temperature was right, the air temperature was right, everything was just right to make the observations. So we took various readings from various heights, starting at 1 metre, 2 metre, 3 metre and 4 metres. We did humidity tests, and there you can see the humidity is still pretty high at around about 70%, so the humidity was still pretty high. If it would have been lower, the observations would have been even clearer. Then we took temperature readings. The temperature was about 70 degrees for the air temperature and about 7 degrees for the actual ocean temperature. So when you get the two temperatures right, that's when the conditions are favourable. If you've got the sea temperature at 0 and the air temperature at 5 degrees, that's when you get a lot of refraction and a lot of atmospheric conditions to actually stop the observations. And this is the actual laser from Worthing to Brighton. And as you can see, if you look in the distance, you'll just see the actual red on the end of that laser beam. Well, that's actually the laser from Brighton, facing in the same direction. And this is our laser set up in Brighton. There you'll see the red laser and the green laser, and that green dot in the distance is actually the laser at Worthing. So it was clearly visible from 9.5 miles. Now you're probably thinking 9.5 miles is not that far really, but even according to the Midwest Metabunk Earth calculator, there should still be a certain amount of curvature between those 2 points. And as you can clearly see there, you can clearly see that bright green dot, yeah, well that's the laser from the other end at Worthing. So just looking at the Midwest Metabump calculator, what you'll see is, firstly, it does two results. One result without the refraction, and there should have been approximately 35 feet of hidden curvature between those 2 points. Yeah, now that's quite a big distance to see them lasers. Now, if you look at it with the standard refraction calculated in, which in itself is actually a pseudoscience, yeah? You know what I mean? The conditions are constantly changing. But even with the standard refraction in, there should have still been 28 feet of missing curvature. Now, the likelihood of seeing those lasers on a globe is actually 1%. Yeah, it's a very, very low odds on seeing them lasers. But as I've just showed you, on a clear day when the conditions are right, you can see them lasers. We could have probably gone to 20 miles that day and seen the lasers. But like I said, we've been there on previous times and you can't see anything, especially when you've got like the ever-changing conditions. And just a little a diagram again showing behind what curve, yeah, because there definitely is no measurable curvature over large bodies of water. And there you can see on Midwest's calculator, this observation absolutely destroyed his calculator, even with the standard refraction. So my question is, where's the curve?
And I thought I wasn't going to get anything that would beat this until I found this photo from Grantmere State Park. This is from Joshua Nowicki. And what you're seeing here is a mirage.
I'm sure you've seen that thousands and thousands of times, you know what I mean? We've all seen that. But what mainstream is trying to tell us is that the Chicago skyline is not really there. You're not really seeing it, really. What's happening, it's magically rising up from behind the curve, and that's the only reason why you can see it. It's absolute nonsense. So, what I did here, I spoke to Jenna about it, and asked her to make some observations. And what she did here, if you look at the bottle on the actual, it's on your left there, and she basically went onto a tennis court, and she put this bottle at distance, and she put the camera low to the ground, and she shot the bottle, and what you can see is that refraction, it actually bends the image downwards. You'll see here, it's actually being mirrored downwards. So the image isn't rising up from behind a magical curve, yeah? It's actually, the light is bending downwards, giving the appearance of curvature. But as you can see, it's just being mirrored downwards. There's no curvature there between these 2 points. This is on a perfectly flat court, yeah, where there's no curvature. But as you can see there, it clearly looks like it's actually being bent down. And I'm sure you've all seen this image before from Lake Pontchartrain. Yeah, this is, I think, is Soundly's proof of curvature. What he did here, he filmed it, and the same atmospheric effects what happened with that bottle is, yeah, the image is being bent downwards, which gives the appearance of curvature. But as I just showed before, yeah, it isn't magically rising up, it's the light being bent downwards. One thing what's always apparent is that the horizon is always at your eye level. So whether you're lying on the beach, you're on Mount Everest, you can always see that the horizon is always at eye level. Now this is an interesting one, because it looks like you can see the curvature of the Earth from Concord at 50,000 feet. But like many things, many of the observations what are made are with a GoPro lens. So what you'll see is, when the image is being panned downwards, you get a convex horizon line. But with Concord sitting equidistant between the barrel lens distortion, it looks straight. So people say, hold on a minute, Concord looks straight, but the horizon is curved. So, but you can clearly see that obviously there is some curvature there, but we'll get to that in a minute. But many people, including Philip Schofield, I'm sure you've heard of him. If you're from the UK, you'll have heard of him definitely, because he's on the ITV breakfast show, and he clearly saw the curvature from 60,000 feet. And how we saw the curvature through Concord's window is beyond me, because like I say, it's a very, very tiny window. And this is from 120,000 feet, and what you'll see is there is no curvature. The horizon is the horizon, the horizontal eye zone, yeah? It's not the curvature of the Earth, it's just the horizon. And Felix Baumgartner, his space jump, yes, you can see clearly there. you can see the curvature of the Earth. This is from 128,000 feet.
And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. So in the photo, you see this curvature of Earth's surface, and he said, wow, he's in space, look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
There you have it, from Neil deGrasse Tyson himself. Yeah, you don't see the curvature of the Earth when you're 128,000 feet up. So anything below that, you can't see the curvature of the Earth. And that's probably the only time I'm ever going to believe Neil deGrasse Tyson, actually. And interestingly, the SL-10 amateur rocket from the GoPro Awards went to a distance of 396,000 feet. That's 70 miles up. Yes, it was shot on a GoPro lens, but when you get the image, get the horizon line, equidistance, what you'll see is the horizon line is perfectly flat. Yeah, so there's no curvature. When does Earth start curving? You know what I mean? We're up to 70 miles now, and there's still no curvature. So next time somebody says they've seen a boat sail over the curvature of the Earth from 6 feet, then you clearly know that they haven't seen it, because you can't see it from up to 70 miles up. If you've ever Googled images from Earth, yeah, what you'll find is there's a lot of cartoons. Yeah, there is no images. And I'm sure you've heard of this guy, Rob Simon, aka Mr. Blue Marble. Yeah, he's a guy who creates the globe, and he's been quoted in saying basically he takes a flat map and he wraps it around a ball. That's what he does in a nutshell.
It is Photoshop, but it has to be.
It is Photoshop because it has to be. Why? So, what we're told then? So we're told we live on a globe and we're orbited by a single satellite, which we call the moon. Yeah. Now, from my experience over the last 3 years and my observations, yeah, what I found is there's no measurable curvature. The horizon is always at eye level, and it rises to the observer, and there's no curvature. So, you know what I mean? I have to start looking at the moon from a different perspective. So what I've started doing, I've started looking at the moon from a flat Earth perspective. So, testing the moon. So, I've done various observations in regards to the moon, and all my observations were shot using a Nikon Coolpix B700 camera. Now, I've had that camera for like over 3 years now. I always use the same focal length when I'm shooting at the moon to keep my observations consistent. Yes, and I always use an app called Ultra, which I've tested on many occasions, and it is pretty accurate. I'll give you a demonstration of this now. So here's the moon, shot recently on the 20th of the 4th, 2019, at 1:39. This is when the moon was at my zenith, and the zenith is when the moon's at the closest to the observer on that night. It's always 180 degrees south for me, being the northern hemiplane, but for you guys down here, you would be actually looking north for your zenith point. And I took a Ultra reading, and Ultra's an app. It's basically a compass app. You point it at anything you want, and it'll give you an azimuth, a direction, or a declination angle. So in the middle, you've got your direction, which is 179 degrees, which is like 1 degree off south. And obviously the declination angle, or the angle from the horizon, which is 27 degrees. So to see if my observations are accurate, what I use, I don't know if you've heard of an application called MoonCalc. What you can do, you can have a look at it, and you can basically see where the moon is, what the phase of the moon is, and how high the moon is. So if you look at the comparison now, so the moon altitude is 26.69 degrees according to MoonCalc, and the azimuth is 179.77 degrees. Just going back to my observation, azimuth exactly the same, 179 degrees, and the altitude or the declination angle is on 1 degree out. But usually, you know what I mean, if you just move the slightest, it can be a matter of 2 or 3 degrees. So the observations I'm making are pretty accurate compared to like mainstream. And you're probably thinking, yeah, you're using mainstream tools. But a lot of the mainstream tools, like planetariums, they're all based on geocentricity. Yeah, a lot of the actual mechanisms in planetariums use Ptolemy's system, which is a geocentric system. It uses equant, it uses epicycles, they use all the kind of geocentric movements to actually create the planetariums, which is quite interesting. So, have you ever heard of the moon illusion, or have you ever seen the moon when it looks really big on the horizon? Now, I've actually debated this previously. Until I actually made the observation myself, I couldn't really, you know what I mean? I look back on it and think I was a little bit of a fool really to say it, because I presumed that the moon was actually bigger when it was on the horizon to when it's like above your head. It looks like a tiny little dot. Now, so what I did, I've got a measuring tool at home, and you can basically measure the circumference, the radius, or measure anything you want really. So what I did, I thought what I'll do when the moon rises, yeah, it looks massive, I'll measure it. So that's what I did, I measured it. I don't know if you can see that measurement there, it's 12,9,313 pixels. Now, that was when it was on rise, and when it was at zenith, when it's above your head, it looks tiny. Oh, firstly, let me just show the metadata first. And notice the focal length at 258.0 millimeter. That's the standard focal length I always use for every observation, which is basically the optical zoom on my camera, which is 60 times. So all my observations are made at that focal length. There you can see just a quick snapshot from MoonCalc to see that the moon is actually on the horizon. And here's the moon at zenith, my closest point. And if you look at the reading there, it's 140159. Now, so the moon actually measures bigger when it's actually at zenith than when it's on the horizon, when it looks massive. It's like they call it the moon illusion, so it is actually an optical illusion. But interestingly, for the given distance of the moon that they tell us, 238,000 miles away, we shouldn't even see any change in angular resolution. There should be no change in size. What is interesting as well is that the moon is actually heading from its closest point to its furthest point, what they call apogee. So it's actually heading further away from the observer, yeah, yet it's actually getting bigger. So that in itself doesn't make sense. There you can see again, I took the metadata to show that the image is genuine, and I collected all the data, mainly the focal length, which is 258.0 millimeter. There again, you see the moon, smack bang in the middle, what they call the zenith. Now, if you look at the distances here, the actual moon distance, according to the mainstream, was 369,834 kilometers away. Yet, when it was at zenith, and it actually got bigger, it's actually 370,670 kilometers away. So it's actually further away from the observer, yet it's getting bigger. How does that make sense? And there's just a close-up there, so you can see the actual changes in size, yeah? 12,9,313 pixels for the moonrise, and 140,159.00 pixels at zenith. So it actually gets bigger. And interestingly, the sun does the exact same thing. I've done the exact same observations with the sun. So when the sun rises, it's smaller. When it gets to solar noon, it measures bigger again. Now, that shouldn't happen at the given distances and the given size of the sun. There should be no change in angular resolution whatsoever. So, one of the questions what I've been asked when I've been observing the moon is, well, if the moon is closer than depicted by mainstream, yeah, why isn't it getting bigger as it gets closer? So I went out and I measured the moon, and actually it does get bigger as it gets closer to the observer, and it gets smaller as it moves away from the observer. So on the this was actually on the night of the lunar eclipse back in the UK on the 20th of January. And I don't know if you can see them sizes, but the width of the moon is 556 pixels and the height is 539. Next reading, like an hour later, width 556, height 552. Width 560, Height 562. See how it's actually getting bigger as it gets close to the observer. Width 566, 566. And width 568, 568. I think there's one more, yeah. And width 571, 571. So the moon is actually getting bigger as it approaches the observer. And just have a look at the measurements again. There you'll see 556 up to 571. So there's a significant change in size. That's actually over 1% change in size between moonrise and being at its closest point, zenith. Let me just click back, because this is something what first got me when I started filming the moon. Now, between 10 o'clock and just after midnight, can you see how the moon rotates? Now, a lot of people don't really notice it until you get a camera, until you shoot the moon at one time, then you shoot it a few hours later, and you're like, whoa, why is the moon rotating? I actually made a video back on this, called Moon Roll Perspective, 2.5 years ago. And I actually got it completely wrong. I'll put my hands up and admit that I got it completely wrong. But what you'll see here is, I think I've found out why the moon does rotate, and it is quite an interesting subject. This is actually the 100% full moon I caught on the night of the eclipse. I just animated it into like a circle just to give you a little demonstration. So, the moon rotation. What I did, I made up this little bit of observation. I basically used my ceiling in my house as an observation point for actually conducting this experiment. And what I did, I placed 4 moons on the ceiling, and I basically calibrated the compass app, so my meridian line, or my point at zenith, which is always under 80 degrees, I made sure that was smack bang in the middle. And so you've got your east to the left, and you've got your west to the right. It'd be the opposite way around down here. And what I noticed is, there you can see my camera position. But what I noticed is, when I actually filmed the actual moon, and then like move from one moon to the next, what you'll see is that it's not the moon that actually rotates. Yeah? That appearance of rotating clockwise is actually the camera moving counterclockwise. Yeah? And as you can see, the moon doesn't move. It's the actual camera that rotates. Now, it took me like 2.5 years to actually work this out, and it wasn't until I put the moons on the ceiling that I actually found out exactly why. And as you can see again, I basically zoomed in on the moons on my ceiling, and you can see they rotate exactly the same way that the moon rotates in the sky. And when I was in London, there was loads and loads of planes coming overhead to land at, I think it was Heathrow. So what you'll see here is the camera is actually turning counterclockwise to follow the plane. And that's basically field rotation in a nutshell. It's not the moon that's magically turning, it's the camera that's actually turning in the opposite direction. Now, some people call this crazy. This is basically from 2 observational points. If we look at the moon from the northern hemiplane, obviously we see the moon in one orientation. And if we look at it from the southern hemiplane, we see it in the opposite orientation. It's basically upside down. So that's what they call crazy, and this is what they call normal. The same observations made on a globe, except one person stood with the feet facing one direction, and another person stood with the feet facing the other direction. Now that's normal, but that's crazy. So that's the reason why you see the moon the opposite orientation from opposite hemispheres, because basically you're just looking at the moon from 2 different directions. One's looking at it from one direction, one from the other. But like I say, that's normal, that's crazy. And interestingly, with the moon being in opposite directions, I did a little bit of a moon sync with my friend Victoria there. And we did a 10,500 mile moon sync between locations. I was in the UK, and Victoria was in Australia. I'm led to believe it's see if I can get it right, Shell Harbour. Yay. So this was Victoria's moon. They can see it, it's in one orientation. She even took a doctor reading to show that she was facing in that direction. So she was facing 282 degrees. And here's my moon in the daytime. Yeah. And there's my reading there. And one thing is apparent, like I'm seeing the moon in the daytime, and another observer 10,500 miles away seeing the same moon in the night time. Some people say it's possible on a globe, but it is questionable, that is for sure. So, hello Mr. Blue Sky. Now, a lot of people have claimed to see stars through the moon. Me personally, I've been observing the moon for well over 3 years, and I've never ever seen a star through the moon. I've seen stars go behind the moon. In fact, I've filmed Aldebaran actually go behind the moon, and it doesn't pop out the other side until it's actually covered the whole disk of the moon. So it won't pop out of the lit side. It'll actually wait till it's actually past all the actual disk of the moon. So you can see blue sky through the moon, but can you? When I went to Fuerteventura, I see the mountains in the distance, and it just reminded me of the moon, where you can basically see the blue light through the moon. What's happening? The light is actually scattering, yeah, because white light scatters very easy because it's shortwave light. So what you'll notice of these mountains at a distance, they actually look translucent. They look like you could probably see through them. But we all know that you'd never be able to see through the mountains. The closer you get, the more solid they look. So this is a daytime moon, and all I did with this moon was add a filter to it. I basically changed the daytime moon into a nighttime moon. That is the exact same moon, but all I've done is added a filter. And it's so uncanny how it does actually look like the moon at nighttime. Yeah, but what is apparent is that disk is always there. So, can you see stars through the moon? I don't believe so. Some said they've seen it, and some said they filmed it, but I'm yet to actually film it myself. And here you can see the light spectrum. So at the ultraviolet end of the scale, you've got the shortwave light, or the blue light, and at the other end of the scale, the infrared end of the scale, you've got the long wave light. So the moon is red. So you're probably wondering, why is the moon red? This is quite simply the opposite end of that ultraviolet scale. At the infrared end of the scale, yeah, the reason why the moon does appear red is because that white light, or that ultraviolet light, can't penetrate the dense atmosphere. So all we see is actually the light from the infrared end of the scale, what is straight from the moon to the observer. That's why the moon does appear to be red. So, as part of testing the moon, I found out there's quite a few cycles related to the moon. You know what I mean? You've got the animalistic cycle. Basically, this is the eccentricity of the moon. So, its closest point to its furthest point. I'm sure you've heard of apogee and perigee. So, when the moon's at its closest point at perigee, it's closer to the observer, and when it's at apogee, it's at its furthest point. That's basically the anomalistic cycle. And that's the one I've actually tested myself. Then you've got the sidereal, the time it takes for the moon to pass through all the constellations and get back to the same point. You've got the tropical cycle, the time it takes to get from the Tropic of Capricorn to the Tropic of Cancer and back. You've got the draconic cycle, which is actually related to the nodes, which is actually related to eclipses. So the time it takes to pass from one node to the next and back again. And then you've got the synodic cycle, which is actually the phases. The time it takes the moon to go from a new moon to a full moon and back to a new moon again. So what is interestingly, they've all got different times. So the anomaly takes 27.55 days, the sidereal 27.32 days, tropical cycle 27.32 days, draconic cycle 27.21 days, and the actual phases 29.5 days. So you've got all these various different cycles with the moon. But what is interestingly is about the lunar anomaly, or the anomalistic cycle, is it's the only one that fits into the 4-year calendar. It actually fits into it perfect. So whatever given distance is the moon, 4 years later it will be at that exact same given distance, although it won't be at the same phase. Well, that's what I'm going to look at now. So, back in August, when the moon was at apogee, I basically took a single shot. I also took a diopter reading to see how far the moon was on the horizon, and again, always using the same focal length, which is 258mm or 440mm equivalent. So it's always at my zenith, which is 180 degrees, and you can see there it's just 9 degrees off the horizon. Then what I do, I always go on to MoonCalc to see if my observations are accurate, because it would be a bit strange if I pointed my one direction and MoonCalc all time and date said he was in a different spot, you know what I mean? So I'm basically using this just to confirm that I'm pointing in the right direction. And what I've done as well, I've even gone one step further. I've even looked at the globe model to see if they're saying the moon's at apogee, you know what I mean? So as you can see there, where it says 32, that's where the moon is at its furthest point. It's actually 32 Earths away, according to NASA, if you want to believe that nonsense. And then I actually measured the moon. So it measured 227 pixels at its biggest points. Then on the 27th of the 10th, 2018, when the moon was at perigee, I repeated the same observations. Again, at my zenith, 180 degrees. As you can see there, the moon's angle up from the horizon, 53 degrees, so it's really, really high in the sky. Then again, what I do, go on to MoonCalc, just to confirm my observations are accurate. You can see there, 179 degrees, 177 degrees, 2 degrees out, but you can see I'm not actually quite in the centre there. If I was in the centre, it would have probably been absolutely spot on. There again, looked at the NASA model. What you'll notice sometimes is that the moon, when the actual points of apogee and perigee, they're not consistent with each other. They're constantly changing. So sometimes it's closer and sometimes it's further, according to the globe model. So there is a lot of questions to ask in regards to the lunar cycle. There you see again, it's actually 248. Now if I just click back onto the, there you go. So 227. So there is a significant change in size with the size of the moon between its closest point at perigee and its furthest point at apogee. And there you can actually, if you look carefully, you can actually see the change in size, you know what I mean? So when the moon is at perigee, it does appear bigger in the sky, and when it's at apogee, it does actually appear smaller. So more observations, you know what I mean? As an observer, it's always good to repeat your observations, you know what I mean? Like I say, you might get one result one time, do it next time, you might get a completely different result. So what I've always done, I've just tried to repeat my observations. There again, the moon is at apogee, 181 degrees at my zenith. What's interesting about this observation is, I was actually in Fuerteventura in the Canary Islands when I made this observation. So I'm actually making the observations from different observational points as well, not just stuck in one place. And I mean, it's always good to get a varied observations. There you can see again, 180 degrees, my point at zenith, and 40 degrees from the horizon. Then again, the moon at apogee. Oh, sorry. Then again, the moon at perigee. Same again, 180 degrees, my zenith. Again, really high in the sky at 56 degrees from the horizon. There you can see, just to confirm my observations. Yes, so 182 degrees, 178. Like I say, it is like a few degrees out, but as you can see the crosshair again, it's not quite in the centre because it's really, really difficult to get the crosshair absolutely smack bang in the centre. And just a quick comparison with the NASA's model to say, yes, according to them, it's at perigee as well. And there you'll see it's actually 250 pixels now, so it's actually a little bit bigger. And the apogee and perigee, you can clearly see with the naked eye although you can't see when you're looking at it with the naked eye in the sky, but when you've got them up close like this, you can actually see the change in size. This is just a quick video to show you the actual change in size as I go from one point to the next. So you can see it's a significant change in size. I think the biggest I've actually measured is like 1.4% change in size. So there you have it. So also, just a quick one here. This is a micromoon. So this is basically when the moon's at its furthest point at apogee, and this is a supermoon. So you can see clearly that there's a massive change in size. So the lunar anomaly, or the eccentricity, or the actual distance of the moon, some call it Kepler's law, some call it orbital mechanics. Yeah, I just call it the anomalistic cycle because that's what it actually is. Yes, we don't know the distance of the moon. Nobody does. They claim to know the distances, but clearly they don't know any distances whatsoever. So just to go through it again, you got the first cycle that I tested was the anomalistic cycle, and I can confirm that there is a point of the moon being close and the moon being further away from the observer, which is measurable. So the lunar eclipse. Now, the only time you're really going to see a 100% full moon is during an eclipse. But just for a comparison, there you can see a 99.9% moon. You can see it's not quite as full. There you go again, you've got the actual full moon, which is absolutely perfectly full. When I first took this shot, and I looked at it, can you see the little black dot around about 1 o'clock? I was like, have I caught a satellite here? So I look back on the video because I took a video footage, and what you'll see is, no, it's not a satellite, it's a bird. So, like I said, the only time you're going to see a 100% full moon is during an eclipse. So it's a really good time to film the eclipse. Now, I must be the unluckiest person in the world for shooting eclipses because I've tried to capture 4, and because of the good old British weather, I've never been able to catch an eclipse myself. On that previous observation on the 20th, it was crystal clear right up until about 2 a.m. in the morning, and the eclipse was supposed to happen at 4 a.m. and guess what? It turned cloudy and I never saw it. So I've got to wait now till I don't know what is it. I think there's an eclipse in July. Then after that, it's 2025, I think. So fingers crossed next time. But like I said about the full moon, the only time you're going to see a 100% full moon is during an eclipse. But something really, really interesting happens. Now I'm just going to go back to the cycles of the moon. So on the night of the eclipse, something really, really interesting happened. Yeah. In regards to the anomalistic cycle, the moon was at its furthest point at apogee. Yes. The tropical cycle, it was its furthest point on the Tropic of Capricorn. The draconic cycle was aligned, because the only time an eclipse can take place is when them cycles are aligned. And the simonic cycle, yes, it was a full moon. So on that night of the eclipse, all them cycles lined up for what I think is quite spectacular. Yes, so I wanted to find out, how long does the moon stay at 100% during an eclipse? So what I did, although I couldn't make the observations myself, like I've showed you in previous observations, MoonCalc is a pretty reliable source. You can go 10 years into the future or 10 years into the past. Yeah, it's pretty accurate, and from all the observations I've made, if anything, it's my observations what are going to be a little bit out compared to MoonCalc. But I call this a lunar standstill for the simple reason the moon on the 27th of July eclipse, yeah, was full at 3:45 p.m. Now, what we're looking at here, you can see the full moon 100.0% to the decimal point. Now, 11 hours, 20 minutes later, the moon is still at 100.0%. How does the moon remain full for 11 hours, 20 minutes? Now, if you think back to the heliocentric model, you've got a stationary sun, yes, you've got an orbiting Earth, and you've got a moon in constant motion orbiting that Earth. How would it be possible for the moon to remain full for half a day? It's impossible in the heliocentric model. And like I say, I've asked this question, I don't know if anybody else could answer the question. I know we've got a few people from the university here. Maybe they could answer the question why the moon remains full for half a day. Because it's, like I say, it is observable and it is measurable and it is actually on time and date of moon cal. But I'm still waiting for an answer for this. I've known about this for probably about a year and a half, and I'm still waiting for somebody to say the reason why the moon remains full for half a day is because of this, and I'm still waiting. But like I say, if anybody's got an answer to that question, I'll gladly hear the answer. So, magnetism versus gravity. So the electromagnetism and gravitation. This is from a guy who wrote a book, and his name is William Hooper. And he wrote, if either of these forces is to be done away with, it must be the mysterious, intangible, unphilosophic attraction of gravitation, which must be replaced by the philosophic and known attraction of electricity, which can be traced to our physical medium, the electromagnetic ether. Now, there is a lot of flat Earth models out there. I don't particularly buy into any models because we know they always have the same old problems with the southern stars and various other issues with various other models. But what I did here, I just basically give my thoughts, my hypothesis. I'm not saying these are the actual facts, I'm just saying from my observations, I've come to these conclusions. Now, the first conclusion I've come to is that the moon is probably just a light in the sky. Yes, although it has structure and texture, what I believe the moon we see from our perspective is probably a projection kind of focal point, you know what I mean? What that light source is beyond the firmament, I've got no idea. But what I believe that the moon we see in the sky is a projection kind of thing. And the reason, one of the biggest reasons for that is if you ever see the moon when it's on a cloudy night, it lights up the clouds locally. But some guy could be 20 miles down the road, and guess what? The moon's lighting their clouds up locally. You know what I mean? It's a strange one anyway. But so, the electromagnetic ether. We know that matter comes in three forms. We've got liquid, gaseous, and solid. But there is another form of matter. It's a substance, what I believe, is on the verge of being supernatural. And that is the electromagnetic ether. And it's a luminiferous substance for the propagation of light. And it carries all the heavenly bodies according to their various heights, frequencies, and densities. And it's made up of two great vortices. You've got one in the north. This is a time lapse with the camera pointing to the north of the celestial pole. As you can see, the stars rotate in a counterclockwise motion. And you've got one in the south, where the stars rotate clockwise. Now, to me, it's clear that we're actually looking at two celestial poles. A lot of people probably say there's one celestial pole, but from my observations, and this southern star trail was captured by my good friend, actually from New Zealand, Paul Kofo72 on the YouTube channel. I'll just play that back again. There you can see, In the north, rotates counterclockwise, and in the south, the stars rotate round a pole point. I'm not saying there's a star in the centre of each one, because Polaris isn't actually in the centre, it's actually a few degrees off, and it will make its own little concentric circle if you zoom in on it or you film it on a time lapse. So, when the moon's in the northern, what I call the northern circuit, it will appear to be circling this. And this is basically a time lapse of the moon shot over a 14-day period at that point where it reaches the southern circuit. So as the moon gets southern declination, it will pick up on the ethereal currents in the opposing vortex and appear to be circling in the opposite direction, round the southern pole. And as it gets northern declination and heads back to the north and crosses over, it will appear to be rotating in the opposite direction in what I call the northern circuit. And if we look at a time lapse from the equator, what you'll see, you can actually see both celestial poles. What's interesting in this one here on the south celestial pole is you can see a sword. So basically, how I see the sky is just like a magnetic field, where you have two poles. One has a vortex motion going in one direction on the North Pole, and in the South Pole we have a vortex motion going in the opposite direction. And what I've done here, I've just tried to give you a little bit of an analogy of what I'm seeing up above. So basically, you can look at the sky as two big wheels. You've got a northern wheel and you've got a southern wheel. One of the wheels rotates one direction, yes, in the north, and the other wheel rotates in the opposite direction in the south. And there you'll see again that time lapse and that image from a magnetic field. They're very, very uncanny when you put them next to each other. There you can see again, look, you just got the one on the actual left is just a magnetic field. That's all it is. And there you can see, and I actually call this the lunar lemur. You've heard of the Anna lemur? Similar but with the moon. And if you go to 69 degrees above, when the moon's high on the Tropic of Cancer, what you'll see is that the moon actually is circumpolar. It's visible for 24 hours a day. Yeah? You know what I mean? But while it's visible in the northern side, it's not visible in the south. But when the moon is high on the Tropic of Capricorn, in the southern hemisphere, what you'll notice is, guess what? It's circumpolars down here too, from beyond 69 degrees. Yeah? And at that point, it's not visible in the northern hemisphere. And just a quick, there you've got like a time lapse, what I call the lunar lemur. There you can see over a lunar month, and you can clearly see that figure of 8 motion. I do believe that the moon is travelling in the infinity sign. So, what is the moon? There's been a lot of questions asked about the moon over the years. Yeah, some people think it's a light. Some people think it's a rock. In fact, 95% of the population think it's a rock. Some say it's a sphere. Some say it's a disk. Some say it's a projection. Some say it's a hologram. So we know that the word moon is derived from the word month, and we know that the word lunatic is derived from the word lunar. Now we've been observing the moon for like a millennia, and we could probably observe it for another 1,000 years and be none the wiser. But one thing for sure, I know the moon, and it's definitely not this, and that's that. That is the Discover Epic satellite, apparently 1 million miles out. Yeah, I just happened to capture a picture of the moon passing by. Now, if you believe that nonsense, then your indoctrination has been successful. And as Elon said it, we have a problem because, you know what I mean, the Earth's a pretty similar size. I know they'll scream angular resolution, but like I say, if you believe that there's a sports car floating in outer space, then your indoctrination has been successful. So, what am I in Flat Earth for? I don't make any money out of it, you know what I mean? I pay my way, I don't monetize any of my channels. All my research is for free, you can use anything of mine, you know what I mean? Everything I've ever done for Flat Earth, you know what I mean? It's always been out of my own pocket. I've got a full-time job, and I fund myself. But, so why I'm in it? All I'm in it is to find the truth. And if I can wake up some people on the way, then I'll feel like I've done my part. And that's it. Thank you very much.